All right, last part that we have to talk about with this integrals for chapter 5/6 is we're going to move on to section 6.2. So this sort of goes over different ideas, I guess we can say. There's two different concepts that are covered on this sheet. One of them is going to talk about solving differential equations, and the other one is going to be talking about rate or exponential growth and decay again. So now we're going to solve more general types of equations by rewriting the equation so each variable occurs only on one side. This is called separation of variables. So when it says to solve the differential equation, what you want to do first is you want to, first of all, y prime, that is the same thing as saying dy over dx. So same thing as saying dy over dx. You're going to set that equal to the 2x over y. Then what you want to do is we are separating variables, which means we want to get like variables together. So if you look at what we came up with here, we have a proportion. Well, the cross products are similar, so we're going to do our cross multiplication. So that means I have the y with the dy and the 2x with the dx. That's what we want. We want x's on one side, we want y's on the other side. Then after you do that, you integrate both sides separately. So the integral of y dy is y squared over 2. If you want to think about plus c, that's fine. And then if you do the same thing on the other side, you get 2x squared over 2, which is just x squared plus c. So you have a second c. Now, because you're going to have two c's, usually what I do is we don't need two c's. I always just forget the first one, and I only put it on the right-hand side, because when you put a constant with a constant, you're still going to get a constant. So you don't need two c's. So I would just scratch the one on the left-hand side for these problems, keep the one on the right-hand side. And then now we have y squared over 2 equals x squared plus c. And your goal is you're solving for c. So then all you got to do is you just need to move the y squared to the other side. So I know I multiplied by 2 there. You do not need to. You could have just told me c equals y squared over 2 minus x squared. This would have been a fine answer. You do not need to. If you want to multiply by 2, that's fine. So we're going to put either or here, but there is no need for you to do that. Ultimately, when it says solve the differential equation, you are solving for the constant value of c. All right, last problem here. Talks about exponential growth and decay. So I do these actually in my Algebra 2 class, but you can definitely... I feel like we've touched on this a little, but maybe not. Let's see. All right, so it says, if y is a differential function of t such that y is greater than 0 and y prime equals k times y for some constant k, then this is the important formula that we want to use right here. Y equals ce to the kt. C is the initial value of y that you start with. K is the proportionality constant. The exponential growth, it occurs when the k is positive, and it would be decay if k is negative. So example 2 says the rate of change of y is proportional to y. So when t is 0 and y is 0, and when t is 2, y is 4. So that sort of gives us two coordinates to work with if you want to think of it like that. T comes before y in the alphabet, so this is like 0, 2, and this is like 2, 4. So the question is saying, what's the value of y when t is equal to 3? Well, there's so many things we have to do before we can even find that. So there is one formula that we use here. What I would suggest, this is always the formula, y equals ce to the kt. So the question is asking us here, remember our points stand for t and they stand for y. T and they stand for y. If you have one that has a t value of 0, that is the one you want to start with first. So we're going to use t equals 0 and y equals 2, and we're going to sub it in. So we get 2 equals ce to the k times 0. Simplify, we get ce to the 0. Well, anything to the 0 is just 1, so that's gone. So now we know what our c value is. We know our initial condition is 2. So we can sub that into our formula. So we get y equals 2e to the kt. Well, if the question is asking what's the y value when t is 3, we still need to know what our k value is. So step 1, we need to get c. We have to figure out what our initial condition is. Now, step 2, and I'm sorry I'm writing all over the place, but it might just make a little more sense than what I have written on the paper there. So second thing we got to find is we got to find our K value. So this is where the second point comes in. So we have our equation so far. So y equals 2e to the kt. And now what we're going to use is this second bit of information. So when t is 2, y is 4. And we're going to sub it into the same formula. So 4 equals 2e to the k times 2. So 4 equals 2e to the 2k. Divide by 2, and we get 2 equals e to the 2k. In order to get rid of an e, you have to add an ln to both sides. So if I add an ln to the left, I have to add an ln to the right. On the right-hand side, the ln and the e cancel each other out, and you're left with the ln of 2 is equal to 2k. So that means k is the ln of 2 divided by 2. These are typically going to be bad decimals, really bad decimals, that go on for basically ever. But in this case, we're going to round it to about 0.35. So that means if that value is positive, this is an exponential growth situation. So now we're going to sub in what we know. So we have y equals, our c or our initial is 2, e, k is 0.35 to the t value. So this would be the formula we would now use for everything. So now the final part is what's being asked goes into here. So when t is equal to 3, what's your y value? So we're going to take our formula we just came up with, plug in our t value of 3, and you end up with 5.66 for your final answer for the t value. So when you get a